Okay, so we're going to look at area of a triangle next in the trig section, and we're going to be looking at the area of a triangle that's not a 9-degree triangle. Right? If it's a 9-degree triangle, then it's just 1/2 base times height, and it's an easy formula, an easy calculation. But not all triangles have a 9-degree angle in them. And for instance, this one obviously has no 90 in it. And just from looking, this might be close, but we'll say that it isn't. And then we have to use another formula other than 1/2 base times height. Okay? Here's the formula for area of a triangle. Okay? So it's A times B times the sine of C divided by 2. And once again, just taking a generic ABC triangle, that's the formula. And the same as our other formulas, even though it's just the one formula you'll be given on the test, you can convert it into 2 other formulas as well. And so this is the one that you put in the notes right here. But you could also put 2 other ones in there, right? The area is equal to AC times the sine of B all divided by 2, and then the area is equal to BC times the sine of A all divided by 2. So you can use any one of those formulas depending on which side you have and which angle that you have, and you could also just rearrange how you letter your triangle to make it work for this formula. There's several different approaches you can take. Notice what is common throughout, okay, is that I've got 2 sides lengths no matter what in order to get the area. And if I don't have 2 side lengths, I'm going to have to use one of my other laws, sine law or cosine law, to find some missing information. So let's do an example where I don't have all the information that I need. And I'm going to have to do some extra calculations beyond just the simple area one. Okay, so let's do an example where my triangle looks something like this. Let's say I have, let's make it look a little closer to what my measurements are going to be. And let's say I have 85 degrees here. This is 3, this is 12. The area of that particular triangle. Okay. So if that's the case, I label it however I like. I have 2 lengths, okay, and one of my side lengths. So this particular one, right, label it however I like, A, B, C. I notice I have length B and I have length A, okay, and I have the angle C. So I can directly solve this one. Area equals A is 3, B is 12 times the sine of my angle, which is 85 degrees, all divided by 2. And you can put that into your calculator in order. I can go 3 times 12, 36 times the sine of 85 degrees, and then I divide that by 2, and I get 17.9. Here's my answer. So let's do a second example where you can't directly solve using a formula. So let's do one like this. I say this is, we'll make this one 100 degrees this time. Let's make this 10 right here. We'll make this 35 degrees. Now notice in this one, I've only got 1 side length. No matter what, each one of these formulas I require 2 side lengths before I can solve it. Okay, so let's label our triangle, because I've got all 3 formulas here. I'm not really concerned about the order that I label it in. It really doesn't matter no matter what. Okay, so I fill that in. Using the angle sum of the triangle theorem, I know that they add up to 180. Okay, So I know that this one must be 45 degrees down here. So now I need to find a missing side. It doesn't matter which one. It can be side C or side B. You just pick whichever one you like. And then you can use the sine law or the cosine law to solve for either one of those missing sides. Okay? I'm going to pick, let's go with side C. Okay? So C squared equals A squared plus minus 2B C. And fill in your information off of your triangle and right into your cosine law. So C squared equals, oops, no, I can't use the cosine law. I need to use the sine law, sorry. Can't use the cosine law here. I need two sides. So let's use the sine law. I've got A over sine A. Is equal to C over sine C. And so I flow information 10 over the sine of 45. Is equal to C, my missing side length over the sine of 35. So cross multiply. Sine of 45 times C is equal to 10 times the sine of 35 degrees. I want just C, so I have to get rid of the sine 45 in front of it. Multiply by it, so I have to divide both sides by the sine of 45 degrees. These cancel out, and I get that C is equal to 10 times the sine of 35 degrees divided by the sine of 45 degrees. And I'm going to plug that into your calculator. I get 8.1. So we fill that in. And there it is. And now I've got a diagram where I can use one of my area formulas. I just pick out the information that I have in order to see which formula I'm going to use. I've got the two side lengths A and C. So the formula that has side lengths A and C is this one. And so then I say that the area is equal to A times C times the sine of B all divided by 2. So my area then is equal to A is 10 times C, which I just figured out is 8.1. There's the sine of B, so B is 100. Divided by 2. B, you plug that into your calculator. And you get 39.9. Don't forget when you're doing a problem like this, if I had units, for instance, if I had centimeters squared to start with, or centimeters as my units, and then your area is going to be centimeters squared. Your area is always in squared units.